Carrick here. To most people, this is what a wind turbine looks like. Different designs are finding new ways to harness the power of wind. Today, we're in Detroit, Michigan to check out a company that makes wind turbines with a different spin. Let's go check it out. Our Renewable Nation, a cross-country eco-video adventure, is brought to you in part by Sustainable Sudbury, a chapter of the Massachusetts Climate Action Network. Hi, I'm Carrick.
Hi, Carrick. I'm Ken Johnson. I'm the president of enviro-energies, and we are at Roush Industries today. That's our partner who's helping us design and make these things behind us here. These are wind turbines.
Whoa. Wait a minute. That's a wind turbine? I've seen a lot of wind turbines, but I've never seen anything that looks like that before. Ken explains the difference.
The kind that you probably saw in the field was called, it's a propeller. They spin like this. They call them horizontal axis wind turbines because you have the axis that the propeller spins on is horizontal. And then this is called a vertical axis wind turbine because you see the axis is in the middle and it points vertically up from the ground. So the difference between these and propellers generally is the propellers need to go kind of out in fields, kind of far away from buildings and away from people. But these are made for like rooftops on buildings or bridges, different man-made structures. And they go up to our big ones go to 40 or 50 feet high by about 200 feet across. They're similar to the big ones you saw out in Texas, those big propellers. They put out the same amount of power those put out, and then we put them on tall buildings, like on skyscrapers you see in cities. This one's 10 feet by 20 feet. Now the sail is, like I said earlier, they're as small as 4 by 8, 4 feet by 8 feet.
How much electricity does this one make?
This turbine will make, we call it a 10 kilowatt turbine, but it'll actually go up to probably about 18 kilowatts. So for a typical house, you need about 5 to 7 kilowatts to power a house. So this could power a really big house, or like a commercial building like this. You can put a bunch of these on the roof. And another thing with vertical axis turbines compared to horizontal axis, the propellers, we've designed these for rooftops. So when the wind, like if you have a roof on a house that's sloped, it's kind of sloped like that, the wind comes off the roof and then it compresses. So at the very top of the roof, there's a lot more wind energy there than there would be down here. And then so we put our turbine right there where there's more wind energy. So what it does is when you do that, your wind down low with that increased energy is similar to having your turbine way up here. So that's what propellers, like the horizontal axis, they put them on really tall towers, and we don't do that. We just put them right on the roof.
So what's that?
But the great thing here, that's the generator. That's where they make all the electricity comes from. See, when this thing moves, like when the wind's blowing and it spins like this, there's plates inside that have a bunch of magnets and a bunch of copper coils, and then they spin. So when the magnets pass over the coils, that's how you create electricity. So then that electricity goes into the wires, and then it goes either into the power grid or into your house or into batteries.
It's really light. Considering it's 1,000 pounds, it's actually kind of easy to move.
Another difference about our turbine is we have magnetic levitation. You know what magnets are, right? You know when you take two magnets and you can't press them together, so they kind of float on each other. So we have those inside the big. That's our generator on the bottom. That's where you make the electricity. On the bottom, at the very bottom, there's two of those magnets, and then there's also in the sail where the white part meets the gray part. We also have those. So what that does is it's like floating on air. So it doesn't. There's no friction. You know what friction is? Where you have metals rubbing against each other. So we don't have any of that. So it helps the turbine operate.
They always knew their way, just waiting on time, taking the small steps they'd need